An embedded system is a computer system, a combination of a computer processor, computer memory, and input-output peripheral device that has a dedicated function within a larger mechanical or electronic system. In other words, I'm saying your mobile phone is an embedded system, your DVD player, if you still have one, or your MP3 player. Our speaker created the Nerves project in 2013 to make Alang easier to use in the embedded systems he used. Nerves has evolved since then, while he maintains key libraries and tools with the rest of the Nerves core team. He's built embedded devices in the consumer electronics, medical, defense, and telecommunications industries, and is currently building equipment for rental real estate at SmartRent. The ability to measure, control, or interact with a physical environment using a small computer is mind-blowing. In the past, these devices couldn't be programmed in a language like Elixir, and now opportunities arise for all of us to reach more than we can do on the web and mobile. There is currently a lot of focus on live books in the community. It can still be difficult to get to use Nerves for this hardware, but the Raspberry Pi board makes it much easier to access and has plenty of support in the Nerves community. So, in the next 60 minutes, the exceptional Frank introduces embedded systems and IoT, shows why the Elixir programming language is interesting for embedded systems, and shows how to get started with the Nerves Livebook. Frank, take it away.
Okay, thank you for that good introduction. And just share. Okay, so I think you just completely introduced my first few slides. So I do want to say a couple things. I saw a few more long-term nerd views on here. So if you're tuning in or watching the recording, this first part is going to be more of an introduction, but the middle part, I hope that you come back around, and because I'm going to be talking more about Livebook and how you can use it with Nerves, doing some simple things and some very advanced things. And I'm super excited about it. So at least for the beginning, I want to set some common ground for what embedded systems are, how Nerves fits into them, what's this thing that I'm going to be talking about is. So when we get to using Livebook, we're on the same level field. Okay, so that's it. So I said all that stuff, but what I really want to do is build things, right? And I think a lot of you do too. So the thing that really got me excited about Erlang in embedded systems was Beam is really powerful and has all these features that are totally made it for the embedded domain, right? We talk about backend, web, all this stuff, and it works for that too, but there's a lot of overlap with embedded. So I want to make this stuff. I want to help everyone else coming onto this project to be able to realize that the embedded-like projects that they want to build, and in my favorite programming language, which is Elixir. So the first thing we need to do is get on the same page on what an embedded system is. And I want to say this up front because if you search the internet for what an embedded system is, there's a lot of variety. So for me, it's a single purpose computer. This is as opposed to like a laptop or a regular computer. You can install anything you want on it. The embedded system, the whole point of this is I have a problem that I need a computer or something that has some computational ability to solve. And I'm going to program that computer directly to solve that one particular problem. Maybe there's some fuzziness with all that you can do within it because there's a little programmability on the user side, but mostly there's a focus on this. Some attributes that make embedded, that are kind of common to embedded is one, this physical interaction aspect. There's a lot of embedded things that you want to build that it just doesn't make sense to put a computer in like some data center. Like for example, if you want to do some sensing like temperature or whatever, it makes no sense to put the sensors in the data center. Like that just wouldn't make sense. You put the sensors where you want to have the sensors. A fairly common use for nerves is inside factories. So of course, if you're going to do some computation inside factories to build a product, or as part of the product building process, it works way better if the computation is done close. And there's almost certainly some sensors that it needs to interact with the thing that you're building and the people doing the building. Another category that's common for nerves is sensor aggregation. I have all these sensors coming in, they're really small. This device is pulling the data from that. The first commercial nerves device was one of these that operated in a boat. Took all the sensors from different parts of tugboats and towboats, combined them together, did some processing on them, and then shipped the result to where the boat captain could see them. So another attribute that we have to keep in mind is reliability. And this is really what got me hooked on the beam, because the beam really focuses on how do I recover from faults that are almost certainly going to happen. Why is this important for many embedded systems? A lot of them are placed in critical locations, right? It's like if something's, electrical power plant, if something's a component in electrical power plant that's, controlling stuff, you don't want it to fail. I mean, likewise, if you have something medical device, you really don't want it failing. It's critical. Another aspect that requires reliability is just remote or unattended use. A lot of these things, a lot of the things that I build are put someplace else. Either, humans aren't around to reboot them or to troubleshoot them, or it's really awkward to, it's the people using this shouldn't have to reboot this stuff. This stuff should just work for them. And they're not qualified to debug them anyhow. So they need to be reliable to kind of keep performing the operation that they want to. So as opposed to your computer, we have high expectations for our computers and like web browsers, but if something hangs on the web browser, restarting the web browser, restarting Zoom, it's not the end of the world. I think we all know how to do that. These devices have to kind of do this themselves. And the final thing I just mentioned is user expectations. User expectations, right? televisions are embedded systems and surprisingly complicated on the inside. And this is not just the smart TV thing, but just getting the video to show, decode it, all the stuff it does. But do you ever expect your TV to crash? Like, that's just not a thing. So you'd return it. It'd get terrible reviews on Amazon or whatever. Even though it's not a particularly important device that runs reliably, it's still the people who make the TVs and the people who buy them expect high reliability. All right. All right. This is the challenge. This is the fun part with embedded systems, in that they're resource constrained, almost always. Not always, but a lot of the ones that I think most of us will run into are resource constrained, just because we can't afford to put a supercomputer inside a little box and make 10,000 or 100,000 of these to sell, because that is a lot of money. Plus, maybe that would probably take a lot of power. So if you have a battery powered device, you may not want to do this. Even if you're plugged in, right? If you're making 100,000 devices, using a lot of power 24/7 all year, it's not a great thing to do. You probably, using too much power generates heat that might cause problems. They're just a lot of constraints on like what kinds of things you can do that are different from like what goes in a data center or like a laptop that you can buy. Yeah, I put a note here, not always resource constrained, and I really want to stress this, is that just because, say, for example, your embedded project required a GPU to do some machine learning, because I think A bunch of us are really excited about NX and we want to do machine learning. That's not a thing yet on Nerves yet, but I hope someday it will be. That does not make the device not an embedded system, right? It still could be single purpose. So that's the definition I like. And if we put in a whole lot of computing power to do something that, because that task that it's doing needs it, then so be it. It doesn't make it all of a sudden a desktop PC. Excuse me. All right, so probably this is kind of the final slide on basic embedded stuff, which is there are two main flavors that you run into on the internet, microprocessor based ones, microcontroller based embedded systems. So there's this rough divide on how you program each one of them. And the importance to this is that microprocessor ones will run Nerves and Elixir, microcontroller ones will not. But that doesn't mean that microcontrollers are bad, less. They are really good and super useful in some circumstances. They just don't have the memory and they don't have the processing power to run the beam. If you're interested in using Elixir and Erlang on a microcontroller, there is another project called Atom VM, which is doing this. So you might want to take a look at that. Let's see, examples that are easy to get for these are, Raspberry Pi is the one I'm going to show a little bit later. For the microprocessor side, for the microcontroller, if you've heard of Arduino, ESP32, stuff like that, that's more the microcontroller side. And I want to say one thing about the microcontroller side is that if you have some application which is hard real time, meaning you have some timing requirements on whatever thing that you're doing, like if it is just imperative that you perform some action every 10 microseconds, or 100 microseconds. If it has a deadline and basically if you miss it, it's really bad. Microcontrollers are totally built for that kind of application. So, all right. See, hope we're ready for some Nerves. So I want to, now that you've had the background for embedded systems, I want to introduce Nerves. Nerves is basically tooling to let you build embedded systems using Elixir. And Elixir, it runs on the beam. You can also use Erlang or LFE if you like Lisp. They all work. Now, when you work with Nerves, you'll see that a lot of us use Elixir a lot. So it will be that I would say is our default place. So let's see. I see a notification that people are chatting. So I can't see the chats. I promise to get to them in a little bit when I'm done with the screen. So I will not miss any questions if they're piling up.
Oh, don't worry about it. Just somebody asked what the name was of the microcontroller project, and I said it's Atom VM. Is that correct?
Yes.
Atom?
Yes.
Good. Then that's already. There's no question for you. Thank you.
Thank you. All right. So where's Nerves used? I learned that a lot of people may not want to invest time in a ecosystem that isn't used in production somewhere. So Nerves is used a whole bunch of places. I want to bring up a couple on the next two slides because I think they're really cool. So on this slide, I have a couple of the farming applications. This was a total surprise to me. When I started Nerves, I had no idea that anyone would use it for farming. I had no idea, possibly because I'm a city person, but what you see on the left is what Bowery does is they have these really big warehouses, like tall, and they have pallets where they have plants in them so you can see them. You can see each pallet. There's a Nerves device on each pallet that monitors the plants growing in each pallet, and they basically the pallets basically start the plants out as seeds and they grow up and then they're harvested and then sent to the market. But the Nerves device monitors the plants, I believe it actuates some watering and other stuff, and has a camera. I don't have the complete details, but I do know that it's instrumental to their system, and they have a lot of these pallets in big warehouses where they grow kind of leafy plants. Then the other cool project that was a total surprise to me was Farmbot, and I think a lot of people who've been around Nerves have seen this. But for those of you who haven't, what this is some people made basically you basically carve out a planter, like, somewhere around, and then operate a little robot that works kind of like a CNC machine, but instead of cutting, it waters the plants, it plants the plants, it weeds. The Farmbot website is awesome. It has a lot of pictures to show what's going on, and inside the whole thing is Nerves. So that one's, oh, and the other nice thing about Farmbot is it's total open source. So if you really want to see a large Nerves project, that is probably the biggest open source one. All right, so then switching gears is, I want to highlight a few factory ones, or ones that are kind of more in places that you wouldn't see that much. Snyder's UPSs, so like power management for data centers. So if you're in, I don't know where you all put your web services, but maybe you put one in a data center that's used some equipment Nerves equipment that manages the power. The Blue Clover device is one that goes in a factory. You're building products and it programs them. And then the Pocket Lancer is a new product that uses Nerves and to bridge PLC systems, which is a special type of embedded system that's and bridges them, my understanding is, across the internet in a safe and easy way so they can be controlled remotely. So that's just, there are more. It's totally fun for me to see if, oh, one thing I should notice, I didn't get permission to say what company this is, but there's Nerves in production outside Nairobi, which I'm super excited. I was really hoping to share more details, but by all of you, there's Nerves in production. So, all right. So what do all these things have in common? They have common networking and concurrency and reliability, right? There's, if you go into like how people built these stuff, or like the details, there are elements of each of these that ended up causing the people who wrote this stuff to look towards the beam. And when they look towards the beam, Nerves was the way that they chose to embed the beam in their product. And I'm not saying that these are the only things. I know that there are a lot of people who just use Nerves more as a hobby or maker. Sometimes in companies, just because the people are just like really good Elixir programmers and not so good C programmers, or just really enjoy programming in Elixir. I mean, you could probably get away with building a lot of things in Nerves. And it's just, if you're going to make the argument, the features of the beam that make it special are the features of Nerves that make it special. All right, and now we get to the next part, which is totally getting started, which is, I thought this was good. So if you would have asked me like a year or 2 or 3 ago, I was just like, oh, Nerves is so easy to get started with. It's like, you just have to do this, build some firmware, flash it to the micro SD card, install a bunch of things. Maybe there's logging utilities, stuff like this. You can see everything. It's super easy. And then I realized it was mostly easy for me and a few other people. And this was causing some friction that, preventing some people I think would love to work with embedded systems, and I'd love to have them be able to participate in the community from actually being able to. Now, having said this, are there hard features of Nerves? Yes, there are hard features of Nerves. There's some hard things that are just hard to do in embedded systems that I don't think that we have cracked that how to make some things easy, but we can do better. And this is where so I want to just say, this is known. if you've had trouble starting with Nerves, I hear you. And these are like the past few years that me, other people on the core team start putting all these little features in to try to lower the barrier in various different aspects of building embed systems. And to be clear, this is not just for people new to embedded. This is for people who do embedded for a living. Like, we all have problems. Making some stuff easier for someone new to Nerves makes it easier for me, right? So we all benefit. But I'm not going to talk about that part because I want to talk about Livebook. So I hope that's all right. This Livebook came out of nowhere to me, and well, also NX came out of nowhere. I have no idea how all this stuff just appeared, but I'm super happy it did. So for those of you who haven't seen Livebook, so these are in the family of code notebooks. So like, oh, it just says participants can now see your screen. So I hope you could see this. So anyway, code notebooks. If you've used Python, there's this thing called Jupyter Notebooks, which I thought was really neat, but it never really meshed with me. Like, I didn't get really excited with it. And even though you could run Elixir code in it, with enough setup, and then all of a sudden Livebook came out, and this whole code notebook all of a sudden became really fun for me because I could take the library, the Livebook library, and just embed it in things, and then run very custom Elixir specific notebooks. So it's Phoenix Live View. It's an app. It's actually not much code. That's, I think, the most impressive part, is that for what it accomplishes, it's really not much, but it is. And I'm not taking away from anything from what Jonathan or Jose have done. I think it's genius that they've been able to do what they can. And I think part of it's due to the incredible building blocks that we have in Elixir and Phoenix. So anyway, their motivation, I'm pretty sure, was mostly machine learning stuff. But all right, I was wondering, and I think a few of us were wondering, so not necessarily my idea. What happens? So I know I have this problem with Nerves with getting started and with explaining some of these hard features. What happens if we combine the two? So let's put them together. So this is me. As you've probably seen, I'm not the best artist. So, but I thought, so I'm just going to go with this for now, but not official. I know that I violated some logo guidelines from a couple people there. So let's review the goals before I start showing the demo, which is I want to get started with Nerves. I want something that's minimal setup. Like, you should just be able to, well, I think the minimum is get a micro SD card, copy the program that you want to run on it, and plug it into at least a decent set of variety of devices. Luckily, Nerves supports a bunch. So my hope is that whatever the minimum is to plug in your devices, that's where we're at. Interactive tutorials. So this is both beginner and advanced users. I want to show off things like, there are things like firmware updates, right? Like there, when you're getting started with Nerves, maybe you start with like blinking LED, and that's cool and all. But when you start deploying a lot of devices, all of a sudden being able to update the software that's running on those devices becomes really important and critical, because, well, it's the way you get new features out, right? And fix bugs, and it has to be rock solid. There's some details. So that can totally be done in there. Livebook can update itself. It can even do some advanced features like Delta firmware updates. So if you're new to Nerves, totally don't worry about what that means. But if you're using Nerves, especially on a cellular connection, I don't know, I think that's kind of cool. So the third goal I had was I wanted to make sharing. Like, so many people in the Nerves community build all these cool things, right? Some of them aren't that big. Like, some of them some of the Bluetooth stuff has been relatively small. Some of the sensor stuff, I want to be able to share that stuff, and I don't want to have to clone someone's GitHub repository, run mixed firmware, or ask someone else to do this. I don't want to have to like figure out how they chose to configure networking so that I can access their device. I want some of the basics set up, but I still wanted kind of in the Nerves boundaries and not just go full like Raspbian or full operating system to run their program. Maybe more. I have some ideas. They're all half-baked. And for I hope to like encourage some of you to maybe think about this, because I totally want to push this technology as far as it goes, and as far as time being like probably the biggest limitation. But I think there's a lot to explore here. So this presentation is kind of like getting started, and hopefully I can put some seeds in some people for to think about other ways we can use this to build useful things and also communicate well to others. So with that, I'm going to get to the best part, because I'm going to do a live demo of using this and on a Raspberry Pi. So if you're seeing my video, it's I have it set up right here, and I'm going to show you the parts. So this, I'm basically going to hook up a Raspberry Pi with a temperature, humidity, atmospheric pressure sensor, and everything else in between is like to make the connection. So the first thing, Raspberry Pi Zero, micro SD card for the data. I'm going through, there's a company called SparkFun that makes boards that have these components on them and makes it easy to hook together. So no soldering required, but if you like to solder, or if you want to solder, you can cut out a bunch of the steps. So here's the Raspberry Pi. This is Raspberry Pi Zero. So this would also work on a Raspberry Pi 3, 4, you name it. If you come across the Raspberry Pi, Nerves supports it. The Zero just happens to be one that I like because it takes one USB cable for power and networking. It's particularly easy for me to carry around. But I don't know what kind of Raspberry Pis are easy to get for everyone. And sometimes people just have, a lot of people bought them and put Raspberry Pis in their drawers. Like, so if you're listening to this video and you're one of those people that bought one a few years ago, didn't know what to do with it and want to do it and want to do something now, even if it's that Raspberry Pi Model B from, I don't know when, long time ago, it still works with Nerves. Doesn't have Wi-Fi, but if you're cool with wired Ethernet, then you can be successful with everything that I'm showing. So let's go over the important parts. On here, I think most of this probably is slightly familiar. So the CPU, the big black chip, the in the middle, the micro SD card, all code and data. There's no code data anywhere else on this board. All of our programs, the beam, all that stuff is going to go on that micro SD card. We're going to hook up to the computer over USB. The USB port, that middle one, if you're using a Raspberry Pi Zero, please use the middle one. That one carries data. The other USB port right next to it is power only. That's probably one of the biggest gotchas for first-time Nerves users on Raspberry Pi Zero, is to plug it into the opposite port and then wondering why networking doesn't work. So on the other side, all those pins, those are the IO pins. That's what those pins carry, the low-level hardware signals that will let us talk to the sensor. So here I have a zoomed in picture of the sensor. So this is massively zoomed. The sensor we're using is called a BME 280. So the text in the middle says BME 280 on it. But it's that silver looking thing with the little dot. in the middle. That thing is impossibly hard just for like me to solder. So I buy these boards that have it already soldered on. And what they did was they took it out to this little connector called the quick connector. That's like the SparkFun, the company branded it that, but there are variations on this. Anyway, the chip, the data really only comes out of a couple wires. And all you need to do is figure out how to get the wires from that little silver chip over to the appropriate connections on the Raspberry Pi, and it will work. This is one way of making it simple. So this is the board that I have, which does the connections. And let me just skip to, okay, I have the micro SD card. I'll get the big picture on the next slide, but there is something important to say on the micro SD card. I already mentioned all the code goes on it. There's also storage. So one neat thing that Livebook lets you do is create new notebooks to write more code. Those get saved locally on the device. You can also pull notebooks off the internet that other people have written and then save them locally if you want to modify them. So this micro SD card's both all the Livebook data and all the storage for any changes that you might want to have. The left-hand side of this drawing, so Nerves, Livebook, the Elixir libraries, and there's a little bit more in this. It's read-only, right? It's like once you build your build Livebook, once I built it and put it on the micro SD card, it does not change until there's a firmware update, which replaces all the code at once. So it's read-only on purpose. That's a reliability thing. It's super important for a lot of industrial use cases but in Nerves kind of like surrounds it with the special language of firmware. So when we say update firmware, we're talking about this left-hand side. The right-hand side where the storage is, that stuff doesn't get updated. It's just like a directory on the file system, and files that you put on there just stay there. Like your program's responsible for what's there. All right. So here's the full setup. So if you can see my video, this quick hat is connected to the Raspberry Pi, and it has a little cable that's going to the sensor. I put a couple labels on this diagram. So USB, to the computer, is both, it supplies power and data, like I said before. This other wire, the one that connects the sensor to the hat, there are 4 wires here. That uses a protocol called I2C or I2C. That's a very commonly used protocol for communicating from chip to chip on one of these boards. It's pretty simple. It's probably the hardest thing about it is realizing how simplistic this is. Basically, all these boards have a number, and you're like, okay, board number whatever, do this, or like board number whatever it is, tell me the temperature, and the electrical signals go through and it does the right thing. And inside Elixir, you get data back, or you can send data. It's not a super complicated thing. It's just the way these devices like to communicate. All right, so when you want, if you have all the starts, or even if you just have a Raspberry Pi, the first step to getting Livebook is to download it. I'll have the URL at the end of my slides. It's on my GitHub, Nerves Livebook. There are instructions for downloading it. It's in the release. You basically go to the releases tab, download stuff. Either run a tool called FWUp or another tool like Etcher that would just write an image to that micro SD card, plug it in, power up. So I'm not going to show that because this part is, is not quite as interesting as the next part. So, all right, so this is live demo time. So let me get out this. So I plugged this in. So there's a network connection going on here, and if I go to nerves.local, so this nerves.local is a special domain name that where your computer will say, hey, anyone on the network, do you know who nerves.local is? And the Raspberry Pi is going to say, I do, it's me. So go to me web browser. And then let's see, maybe I can make this bigger. So hopefully you all can see this. And so this is just what you get. If you run Livebook locally, this is going to look really familiar. So normal thing to do, here I'll just click around. So this is running, Livebook's running on the Raspberry Pi Zero. Nothing's, my PC is just being used as a web browser. And so with Livebook, you get, like little text sections, you can write comments, you can write code. So if you could evaluate, it will run that piece of code in Elixir. And then hopefully you can see you can write these documents. So how does this, so let me go back to the beginning. Why is this interesting for Nerves? Well, Nerves Livebook comes with a bunch of samples. And there is, for the sensor that I want to show, someone in the Nerves community, his name's Masatoshi Nishiguchi, he wrote a little Livebook for using the sensor. So I'm going to load his Livebook. So let me, so if you run this, you'll see, and he has like a little tutorial, which he set up the sensor a little bit different than me, but you can see he has pictures for how to work through this, the wiring. So he wired this directly with the little cables. So, and he goes into a lot of description. So if you want to know like the next level deeper on how the sensor's wired up, just read through his tutorial. But here, this is the fun part. Okay, so this is where the code starts. And so the first step is the sensor in there. So there's a detection step. And you know how I was saying that I2C likes to number devices? So it found 2 devices. And so cool, 2 devices are found. One of these I know is a sensor. So let's see. Then he says, initialize BMP 280 server. Oh, hang on. All right. So I got an error. All right. We want to make sure the sensor board is right. Okay. So he says most sensors are at address 77, but some are at 76, and I'm at 76. So let's see. So let me just edit his script, because I am one of those. Okay, good. So fixed. So the BMP 280 library that he's using here started, says okay, gave the PID. So all's good. Then the next thing we can do is see what the sensor type is. It's a BME 280. So this library supports a whole bunch of sensors. So it got my sensor right. I'm happy at the moment. And so here's the key part. So ready to read data. All right, so it read data. So let's see. I guess the interesting things are it's about 24.5 degrees C here in this room. 60% humidity. Oh, here, let me get rid of that message so I can keep on reevaluating it. I'm not sure if you can see things changing. They might be changing a little bit. I'm looking at the timestamp, so every time I reevaluate it, it does another sensor measurement. So hopefully that's cool with everyone.
Very cool.
This guy, okay, okay. This like was the most exciting thing for me, because prior to this, you know, like setting up these sensors is like a decent amount of typing, and we do through the IEX prompt, which I thought was awesome, because when I was programming in C, I have to write a C program, compile, and all this. And now it's just like, oh, I can just read through this book, this notebook, and you know, as I'm reading, just evaluate, and it does stuff. And now there's fancier stuff in here, because the sensor can do, the sensor is super cool. But I want to talk about another Livebook feature. And so let me go back and hang on just a second. The Zoom window's on top. All right, so now that I can get temperature, like what if I wanted to just like graph this stuff out? And because that would be a really nice way to kind of see how this sensor is working. It'd be, I think it'd be really rewarding, you know, that this hardware setup is doing what I want it to do. So luckily, Livebook comes with integrations with something called Vega Lite, which does all this charting. So there's a little Livebook tutorial on how to use Vega Lite, and there are a lot of charts that you can do. And then there's this thing called Kino, which lets you pull those charts in and more into your Livebook. So I don't know much about either of those, or I didn't. So what I did was I went to those Livebooks, and then, you know, I can go down here, hit evaluate. It evaluates these, and okay, this wasn't the good one. Oh, it says push data. So you see they have this little demo of a sine wave that that you can do, and you can see the code here, and that's all good. But it's not something that's continuous, right? I kind of want something that's continuous, and of course, they read my mind and basically made it the next thing, which is this periodical updates. So if I evaluate it, I can kind of see that I have this little section that sets up my chart properties. And then I have a little section here, which this periodically function says it calls whatever function you pass it every 25 milliseconds. And then they do this thing where they push points to the widget that they made, which is this graph. So cool, right? So let me do the thing that I'm good at, which is copy and paste. So let me I'm going to copy this because go back. So one thing to notice, the notebooks are running. So, or, you know, when you start up a session, they'll carry on. So you can kind of work with multiple books simultaneously. So let's go to Masatoshi's book, and where were we? We were here, reading data. So if I reevaluate, I'm not sure if this is coming over Zoom, but it is updating. So let's just put down something like let's graph your, oops. And then let's have like a little Elixir section, and I'll paste. Okay, so let me make sure I do this right. So create the widget, and then run this callback. I'm going to slow this down. So I'm going to run it every 100 milliseconds. And then here, I don't want the sine wave. I want, I just for, the X coordinate, I'm just gonna have this be the sample, like, the first sample, second sample, third, so on, because that seems easy for now. Oh, I need to get a measurement. So let me copy and I'll get a measurement. And then for the Y coordinate, I'll do measure, and I don't know, this is another thing. It has tab completion. I think this is sweet. So, all right, so I want temperature and I'm going to tab. Look at that. I don't know. It's all these little things that are just really, really kind of cool in this whole thing. So let me evaluate. Oops. Alias. See, Vega, like they did that, I think. So I do this. Okay, so 24 degrees. So I'm going to put my thumb on the sensor and hopefully it'll go up. So
nice.
And then if I let my thumb off. So, okay, that's it just keeps on going. Let's do it again. I don't know why. The problem with these Zoom presentations is that I can't really see all of your faces, but that's okay. This is almost entertaining. Just okay. Let me move on then. All right. So I hope you all can tell that I'm just having like way too much fun with Livebook, and this is just one demo. So let me go back to the slides. Okay, did that. Okay, so sadly, it's getting closer to the end of the hour, so I have to sum up. But I want to tell you some advanced things that are possible. You can do a bunch of network setup and experimentation. So networking with embedded devices, at least the ones I work on, is super important because we have a lot of services like that need to contact the cloud, or there's just some interactivity that has to be there. So maintaining a stable network connection is important. Nerves has a lot of libraries to let you have multiple network interfaces and deal with them. So you can experiment with that. Firmware updates, I mentioned this. But one of the first things I did with Livebook was to see if I could have a Livebook that let you click evaluate to see, like, do I have a firmware update? And if I do have a firmware update, go get it and then check it. Is it signed properly? Is it did it get corrupted when you went download it? I don't know, but you can check with this notebook, and then you can apply it or reboot and get you the new software. Another thing, Erlang distribution works with Livebook. Livebook pretty much sets this up by default. I've modified to make it a little bit more friendly with predictable node names. So you can connect to it from your PC over Erlang distribution. That lets you do some things, and I wanted to let you do some more things, but that needs a little bit more work. The other thing, for those of you who use Nerves, debugging nerve systems is both easy and really hard. Like, there are a lot of tools available, but it's a little bit hard in knowing where to begin. So I've been wanting to get these a little bit, make the debugging options more accessible via these Livebooks. And this is perfect because this Nerves Livebook application has a lot of stuff going on. So it's kind of neat to introspect. Okay, all right, review. Learn about embedded systems. I like them defined as single purpose devices. There's usually some physical interaction aspect. Reliability is important. Resource constraint is important. And as you saw, Livebook ran great on this. I mean, it's a testament to a lot of the technology that we're built on, that Erlang and the Beam run so well on a little Raspberry Pi Zero, which, granted, if you've been in the embedded systems community for a long time, you'll be like, oh, it's really fast. But I mean, it's not that fast. And for a lot of things that we ask it to do. So it's kind of cool. Nerves is one of several ways that you can build embedded systems using the Beam. So one of several. There are other ways. I really like Nerves, but it's not the only way. And Livebook, here's my hope. My hope is to lower the barriers to using Nerves and for advanced users to get into being able to integrate some of these really neat features that are in Nerves that are a little bit harder to use right now. And of course, much more work. So last but not least, if you all want to get involved, please do. I'm curious to see where we can take this. Like, I think it would be like just fun experimenting with this. I'm sure we'll fail in a whole bunch of different ways, but I'm kind of excited at the opportunity for this. Any feedback, like, you'll see documentation is really hard. So feedback for getting, for using this is definitely appreciated. And one special note, if you're interested in Bluetooth, Jason Axelson has forked the Nerves Livebook. There's some technical difficulties where I can't have Bluetooth Livebooks in the main distribution, but he totally made it so you could. And he does a bunch of stuff with that. So anyway, look, if that's what interests you, go to Jason's GitHub. And this is it. Thanks everyone for listening. And let's see.
Nice. Thank you very much.
Let's see. Get to chat. Cool. Yeah, so easy.
So is this the Q&A time?
This is Q&A.
Okay, well, first of all, I want to say that actually that was a lot more compelling than I thought it would be. So good job. So I have 3 questions. So I imagine that a lot of the Nerves community is using Raspberry Pi. How reliable have you found that in practice?
So I would say, I'm not completely sure that's true. I think Raspberry Pi is the most accessible thing for people to use. For a lot of the projects that get posted on the internet, and I think for industry, I guess it's hard to tell stats, but I'd say that from my experience, I lean towards more other processors rather than the Raspberry Pi because I find them way easier to.
Could you give a suggestion?
Because
I'm not familiar with this area at all.
Okay, so this is a particularly old BeagleBone. So, but the BeagleBone processor is tried and true. This is so I guess here's one device that I use for work. This is a custom board. It basically uses the same processor as in this BeagleBone. It's a Texas Instrument AM3358. Not a particularly new processor, but the software for it's pretty solid, so it's nice to use. The other ones that I like are NXP has IMX6. That's pretty popular. There's an unofficial Nerves port that uses IMX6. The GRISP2 board uses IMX6. That one's kind of a neat processor. It's definitely newer. There's a processor from ST Micro called STM32MP1, which is really cool. That one, I think that one's relatively new. So I think I only know of like 1 or 2 companies like pursuing that processor. So I think that I think it depends on your app, but what makes sense to you. But like having the U-boot bootloader is particularly convenient, and these other processors have it. The Raspberry Pi has its own bootloader, which is kind of a little bit trickier if you're worried about like failures like the Linux kernel. The Linux kernel crashes like on boot, and you can have failback mechanisms with Nerves, like for the work devices, if the Linux kernel crashes or, midway through boot because who knows what, bad firmware or whatever, it'll revert to, it can be set up to revert to the previous firmware. And that's way easier with U-boot than the Raspberry Pi way. I'd say is limit on that. Now, I guess the one thing I would note, the Raspberry Pis are amazingly good for what they do. Some people have abused them pretty much, so I don't want to be down on them either.
Okay, the other question I had, second of three, is so the Raspberry Pi is about 512 megs, I believe. I have a good feel for what C can do, but not so much on a resource constrained device for Elixir or Erlang. How much do you feel that you could reasonably do with a 512 meg device using Nerves?
Okay, so the ones I use at work are either 128 meg or 256 meg. I guess, we do have some 512 for the most part. So if I find that for the applications that I use, now they don't have displays. So as soon as you get a display, then things balloon up quite a bit. So the applications that I use at work are more like these headless devices that take in sensor data, maybe have a web interface, with Phoenix. They totally work fine in like 128 and 256 meg. 512 seems just completely spacious.
This is the kernel plus Beam plus your application on 128 megs.
Yeah. If you just don't want to worry about it, go with like 256. I mean, 128, I think if you start doing too much, you'll bump into a bit and maybe have to optimize. Like most of the time, I like a lot of room. So let me just say I'm very conservative on the space I have because I don't want to deal with a lot of this stuff. So if you're making something new, I doubt that, unless there's a huge cost difference, which for me there hasn't been. I just take the 256 and just not worry about it.
Okay, and the last question I had was, of course, Livebook is pretty cool. If I had a device, though, that I didn't want just anybody logging into, how difficult would it be to add some TLS to that?
I have not tried adding TLS to Livebook. With Phoenix stuff on other projects, the people who've worked at it have added TLS to it. I gotta believe that it can't be too hard, but I honestly just don't know. I'm not really a Phoenix person. I mean, the Beam has an OTP have all this stuff built in, so it's probably just a matter of has someone taken the time to expose the configuration settings out to where it's easy and convenient. And it's not something I'd worry about, even though I don't have a good answer for you.
Well, anyway, that was very interesting. So at least from me, thank you so much for the presentation.
Thanks. Yep. Yeah, I see. Yes.
No other question.
There's yeah, I'm excited about the Pocket Lancer. That's cool. See it finally released.
I have a question. First, thanks, Frank, for the update with Nerves. What about the making clusters or like building Beam nodes with Raspberries? Do you know details about the performance, how difficult it is?
As for most difficult thing is just making sure that is just setting up the Erlang distribution. So if you know how to set up Erlang distribution just on a regular PC, it maps almost exactly to the Raspberry Pi. You basically start EPMD, and then you set the node name and set a cookie, and then ping everybody that you want to ping. The trick is more in easily figuring out who to ping, right? Because sometimes these nodes come up with different IP addresses if you have DHCP. You know, it's not like you could, if you're okay with hard coding IP addresses, not a problem. If you have like if your router, your DHCP server and DNS are integrated, so that your router can make can register the name of the node. So like these things come up, like this one, the one that I have comes up as nerves dash and then a couple numbers. Then that's really easy. You just record the serial numbers for every and just ping everybody, and then you'll have the node. How far this thing grows, I don't know. I've never done Erlang distribution more than a few nodes, so might be fun experiment to see. So
Thanks.
does that help?
I think I'll have to cut this short. However exciting this was, still is. So I'd like to, could we contact you via Twitter for more questions?
Yep.
I'll
Yep.
leave Twitter handle in the chat. But in the meantime, thank you so much from the ElixirKenya fraternity. Like, to make this webinar happen, it involved work and people, and of course you yourself. So thank you so much. We've learned a lot. We hope we'll have another session of the same like this sometime. So if you still have time, people, do you still have time to take more questions before I stop the recording to let anyone who is rushing somewhere to go?
I have a tiny bit more time, but not much, but I'm available. You can find me on Slack, Twitter. I'm around. I'll forward you my contact info, and slides if you'd like them.
Yeah, I think we'd like that. We'll talk,
Cool.
we'll reach to you by email, but anyone else, here is his Twitter handle. Thank you.
Yeah, thank you for having me. This was a lot of fun. It's really nice being here. Thanks everyone for coming too.
Thank you for the nice presentation. I learned a lot.
Cool.
Shoaib says I should stop using the word fraternity. I hear you quite clearly. I will stop.